Hey, welcome back to Easy Learning 77, your complete Algebra 1, Semester 1, standards-based course. This is just one lesson out of many. If you haven't done so already, please visit tinyurl.com/easylearning77 so you can see our entire course and everything that we offer. Thanks, and let's get started. Okay, so in this lesson, we're going to talk about how to translate English into mathematical expressions. And so English phrases can be converted into math expressions, and also math expressions can be converted into English. So here in the lower left, we have this young lady, and I don't really know why she's wearing a watermelon on her head, but she is. What I can't tell you is this: since watermelons are kind of circular, she's thinking about circles. And so she says in English, circumference is the product of 2 pi and r. So she says that in English. Well, over here on the right, I have 3 math teachers. And they look just like math teachers, don't they? One has red hair, one has blue hair, and one has pink hair. So they hear this young lady say circumference is the product of 2 pi and r. She says it in English. But our mathematicians, they all think in terms of equations and variables and those kind of things. And so our red-haired math teacher here, he thinks C, which is circumference of a circle, is equal to 2 times pi times r. So he hears the English phrase and he converts it to a mathematical expression. So let's just look at this just a little bit. This is written probably the way that you're used to seeing multiplication indicated, 2 times pi times r. You are probably used to seeing multiplication indicated by an x, and there's nothing wrong with that. But as you're moving into algebra now in higher level courses, there are always several ways of saying the exact same thing in mathematics. So our blue-haired math teacher here, here's the same exact English phrase. And he thinks of it like this: 2 pi r. Notice I have an equal sign here in white because what my red-haired math teacher thought of is equal to what my blue-haired math teacher thought of. So what I'm trying to tell you is this: these are both the exact same equivalent ways of saying the same thing. When I indicate a mathematical expression as 2 pi r, what I really mean is 2 times pi times r. There's no plus sign in between them. There's no minus sign in between them. There's no division sign between them. So when there's no mathematical operator in between our symbols, that means everything's being multiplied together. Well, our pink-haired math teacher, he also heard the same English expression. And here's what he thought: 2 times pi times r. So a third way of indicating multiplication is to have that dot. It's kind of like this x up here. This x means 2 times pi times r. Well, down here, that dot means the same thing: 2 times pi times r. So our 3 math teachers each heard the English expression and they converted it into 3 equivalent math equations or expressions. Okay, so we're going to be looking at different words that when we read a word problem are going to give us a clue that we need to use a variable. Remember, a variable is usually a letter like X or T or A, which represents some number that we don't know what it is. So if you're reading a word problem and you see something like a quantity or a number or some value or something is unknown, that's a clue that you're going to have to use a variable. So in your notes, you really should put these 4 words here and say these mean a variable. Remember, you can always pause the video or rewind it and pause it if you need to slow it down and take notes, or go back to review. Nothing wrong with that. Let's look at an example of when we would have to use a variable. So when we see words like quantity or some value, we're going to have to make a variable. Let me give you an example. You might be taking a test and it says a quantity of hydrogen is used in an experiment. So there's no constant value. Remember, constants are simple numbers like 10 or 20 or -5. So in this problem, there is no constant value given, such as 5 grams, for example. That means that the value is unknown. It could be 5 grams of hydrogen, it could be 7 kilos of hydrogen, or it could be 22 pounds. We don't know. But since the value can vary, we're going to use a variable such as H to represent this unknown quantity. I use H because I'm talking about hydrogen. So we will use, since it's an unknown value, it's some quantity, we'll use a variable H. Here's my next example. Again, we're talking about words that tell us we need to use a variable. So if you see something on a test that says a number or some number, it's giving us a clue that we have to use a variable. So no constant value is given. So the value can vary. In other words, it could be 10, it could be 20, it could be -55. We don't know. So a variable should be used. Let me give you an example. You're reading the word problem and it says this. A student works a certain number of hours. So that tells us that we don't know how many hours it is. So we're going to use a variable. For example, you could use X can be used to represent that variable. But maybe better would be to use N. N might be a better variable since it represents the number of hours. So when you're working problems out, if you're talking about number of hours, you might want to use N for hours or maybe H for hours. Here's another example. Still talking about words that make us think about variables. So I could say something like on a test like some value, something's unknown, or how many. So we don't know. There's no number mentioned. Let's look at an example. Juanito, and here's a picture of Juanito. He earns $48.60 per day working at Burger. So here's the question. How many days must Juanito work to earn $6,500? So we don't know if he works 10 days. We don't know if he works 50 days. We don't know. But we'll have to set up an equation for that. But we're not going to do that yet. All I want you to learn right now is that Juanito must work some number of days. The exact value is unknown. So we can use a variable such as D to represent the unknown number of days. D for days is our variable. Okay, so we're learning how to convert English into mathematics. And so we looked at a while ago at some words that tell us that we have a variable. Well, next we're going to look at words used to indicate addition. So on my right side here, I've got some words that when you see them in English, you start thinking addition, adding things. So words like plus, sum, is increased by, is greater than, is bigger than, is more than, or the total of means we're going to be adding some things. Okay, so we're looking how to convert English into mathematics, and we're looking at examples where you're going to use addition. So here in this first example, I see if you were to read in a test x plus 5, that's pretty easy to understand. We have something called x plus 5. That would be our math expression. But they could also be given to you like this, a number plus 5. So when I look at this, a number means I don't know what it is, and so since I don't know what it is, I'm going to use a variable. In this case, I just used x. So I'm going to get x plus 5. Okay, another English expression that could give you x plus 5 as your math is the sum. Sum means addition, so I'm going to add x and 5, x plus 5. Okay, and this next sentence right here, I've got the sum of a number and 5. So again, a number is going to tell me I've got a variable. Sum tells me that I'm going to add, and I've also got the 5 there. So I've got a variable number and a constant 5. Could also see this. X is increased by 5. Increased means that something gets bigger. So I've got this variable X, and it's going to get bigger by a factor of 5. A quantity, again, a quantity, we don't know what that quantity is. So we could use X as our variable. And so I could come up and say that a quantity increased by 5 means X plus 5. Okay, here's another way of stating this. X is 5 greater. So that means that X is bigger than something by 5, and I can see bigger down here. So this means I've got a value X, and it's 5 bigger than, or I'm adding 5 to it. All right, a value is 5 more than. A value means we don't know what it is, so that's a variable. 5 more than means it's getting bigger, and so here's my value, which we don't know, and it's gotten bigger by 5. Okay, another way of saying this is the total of. Total means I'm adding things up. So the total of X and 5. Okay, so we've talked about words that tell us that we're going to use a variable. We've looked at words that tell us that we're going to do addition. And so now we're going to look at words that tell us that we're going to use subtraction. So I've got 2 boxes here. On the left, I'm going to put some English expressions. On the right, we'll put the equivalent math expression. So first off, let's say you're taking a test and you see X subtracted from Y. So subtracted obviously means we're going to do some subtraction. We're going to do minus. The only thing in this is a little bit hard to figure because it says that X is subtracted from Y. So the equivalent math expression would be Y minus X. So X is being subtracted from Y. Okay, let's look at our next English expression. We get A minus B. So minus usually means subtraction, as you know. And so I get A minus B as my algebraic expression. Let's look at another example. The difference. Difference, that word difference in English on a math test always means subtraction. And so I've got 2 words here, temperature and pressure. The difference between temperature and pressure. Well, we don't know what the temperature is. We don't know if it's 55 degrees. We don't know if it's 60 degrees. The pressure, we don't know. So I'm probably going to have to take 2 variables. I don't know what temperature is. I don't know what pressure is. So when I set up my equation, I'm going to use subtraction. So here's what we're going to get. Difference means subtraction. And so we're going to get T for temperature minus pressure. P for pressure. You can use any variables you want, like X and Y or A and B or whatever. But since we're talking about temperature and pressure, I think T is a better variable to use and P is a better variable to use. Let's look at another example in English. 5 less than the average. So less than means that something's getting smaller. So when something's getting smaller, a quantity is getting smaller, that indicates that we're subtracting from it. We're making it smaller. It's getting less than. So again, we don't know what the average is, but I could use a variable to indicate that average, like A for average. And so what I'll get is 5 less than. So we're going to subtract by 5 from the average. Another way of saying that is 5 fewer than. Again, fewer means something's getting smaller. And so 5 fewer than the average would be the exact same algebraic expression. The average and then 5 subtracted from it. Finally, the population decreased by 2,000. So decreased means something's getting smaller, so we'll use subtraction. Population, we don't know what the population is. It could be 1 million people, it could be 10 billion people. We don't know. So I'll use a variable P. Here's our algebraic expression. P is my unknown population, and I'll decrease it by 2,000. Okay, so let's go ahead and do a brief review of what we learned so far. We learned that English can be converted to math, and math can be converted to English. So here we have a young lady who is a business person, and she says in English that profit is income less expenses. So over here we have another young lady who has a singing business, but she's also a mathematics major. And so she hears our business lady over here say profit is income less expenses, and she thinks P for profit, because we don't know what the profit is equals income. We don't know the income, but we know it's a variable, so I'll use the variable I, less, it's getting smaller, so she chose subtraction, less expenses, so E for expenses. Profit is income less the expenses. All right, so we're still reviewing, and so we're going to look at when we would use a variable. So this problem is actually from the 2017 STAR exam in Texas. And part of that problem states this: a particular type of cell doubles in number every hour. Which function can be used to find the number of cells present at the end of h hours if there are initially 4 of these cells? So let's think about this for a minute here. One of the things you always want to look at in a word problem, which is in English, is what are they asking you for? Are they asking you here for the number 4? Are they asking you for h? No, the word find means that that's what we're going to look for. So we're going to find the number of cells present. So let me ask you this. Is the number of cells present a constant or is it a variable? Do we know what that number is? Is the number of cells known or unknown? Well, we don't know what it is. That's what we're trying to do. We're trying to find what that is. So I'm going to use n as a variable, and I'm going to use it to represent the number of cells present. We don't know what the number of cells is, so that will be a variable, and I'm going to use n to represent that. Okay, let's look at another problem. Again, we're still looking at variables and when to use them. So this problem, again, is from the 2017 STAR exam in Texas. We're not going to solve it completely, but we're going to start dissecting these problems so that you know how to take these tests and pass them easily. So here's our problem. A drummer and a guitarist each wrote songs for their band. The guitarist wrote 8 fewer than twice the number of songs that this drummer wrote. They wrote a total of 46 songs. So which system of equations models this situation if the drummer wrote D songs and the guitarist wrote G songs? So let me ask you a few questions about this problem. If you need to pause to think about it, go ahead and do that. Or you need to rewind, go ahead and do that also. First question. In this problem, I see this 8 here in green. So is 8 a variable or is it a constant? 8. Correct, it's a constant because 8 is a value that never changes. Let me ask another question. Here we have this letter D. It says the drummer wrote D songs. So is D a variable or is it a constant? It's going to be a variable because we don't know how many songs he wrote. We just know it's going to be D. We're going to call it D. So D could be 0 songs, it could be 20 songs, it could be 5,000 songs. We don't know, so we'll make that a variable and we'll use D to represent the drummer's songs. Here's another question. Here's this letter G. It says the guitarist wrote G songs. So is that G, is it a variable or a constant? You should say a variable because, again, we don't know what it is. It's not 8, it's not 50, we don't know. It could be something. All right. Let's keep asking you some questions. So here's another question. Right here, it says, does 8 fewer than? Right here in green, it says the guitarist wrote 8 fewer than twice the number of songs that the drummer wrote. So let me ask you this, 8 fewer than, is that addition or is that subtraction? Fewer. So it's getting smaller. Fewer means that something's been decreased or made smaller. And so we're going to use subtraction because when you use subtraction, that means you're taking something away. So right here, I'm going to get this minus 8. Fewer than will tell me 8 fewer than. And actually, I'm kind of getting ahead a little bit on the lesson here, but it says that twice the number of songs that the drummer wrote. So twice means 2 times. So I'll get 2 times D and then 8 fewer that than. Okay, remember right here this 2D, since there's no plus or minus in between, that means that we're doing multiplication. 2D is twice D. Okay, let's look at another example. Here, this is still the same problem. We're going to look at one more thing on this problem. Here in red, it says they, meaning the drummer and the guitarist, they wrote a total of 46 songs. So total. Does total song mean addition or does it mean subtraction? Well, if you look back at your list, which you should have in your notes, total means addition. So I'm going to get a plus. And actually, so what this is saying, that the drummer plus the guitarist wrote a total of 46 songs. I could also say the sum of the songs is 46, or I could say the drummer's songs plus the guitarist songs is 46. So these are different ways of indicating addition. Okay, it's time to practice what we've learned. So your teacher may have you work with your shoulder partner or individually. So here's what you and your shoulder partner might look like. And if that's what your partner looks like, tell him to stop clowning around, get to work. No matter what your teacher asks you to work, each student must turn in their own work. So rewind and pause the video whenever you need to review. If you get lost or you get stuck, ask your shoulder partner. That's what they're there for. And if you still can't figure out what's going on, then ask your teacher. Work all the problems on a sheet of paper and don't forget to turn them in when you're done. And put your name on your work. Good luck to you. Okay, it's time to do some problems on your own. So copy these problems onto a sheet of paper, pause and rewind the video as necessary, and good luck to you.